here we have a magnet, and here we have a paper clip. Now if I put this magnet closer and closer to the paper clip, watch carefully what happens. Notice that the magnet is not touching the paper clip. Did you see that? This is what we call magnetic force. Even though the magnet doesn't touch the paper clip until it pulls it to it, it has that force on it. You can see that its force is so strong, it pulls the paper clip across the table to the magnet. It's incredible. Now, are all objects magnetic? Well, let's test some different objects. So here I have some magnets, and here I have another object, a bouncy ball. Now, do you think that this bouncy ball will be attracted by these magnets? I want you to think about it in your mind and get your prediction. Decide what you think will happen. Often in science, we like to make predictions, and a prediction is our guess of what we think will happen based on other things that we've learned. So now let's try it. Well, it doesn't look like it's being attracted. If I put the magnet right on here, are they sticking together? No. See how they're not sticking together at all? Well, this bouncy ball is not attracted to the magnet. This magnet has no magnetic force on this bouncy ball because the bouncy ball is not a substance that is pulled by a magnet. Well, let's try a different object. How about we try this pin? Well, set it on the table. I'll move my magnets close to it. Ooh, this one is attracted by a magnet. See how the magnet can just hold it? We can see the magnetic force working here. So this pin is attracted by the magnet. Let's try something else. Let's try a banana. Well, if we put our magnet on the banana, notice that there's no attraction here. Absolutely no attraction. Well, bananas are not a substance, sticky there. Bananas are not a substance that magnets can attract. So what are you noticing here? Well, we've tried a banana and a bouncy ball, a paper clip, and a pin. Which of these objects were attracted by the magnet? Well, that's right, the paper clip and the pin. Well, notice that both of these are metal objects. Both of these that were not attracted by the magnet are not metal objects. So we've learned something. Often, metal objects can be attracted by magnets. Well, let's keep trying some different substances. Let's try this penny. Now we know that pennies are made out of metal. So let's see if pennies are attracted by magnets. Well, there's absolutely no attraction here. There's no magnetic force. Well, not all metals are attracted by magnets. Only certain metals, such as iron, nickel, and cobalt. Now, many objects that we use, are made of more than one metal mixed together. But in order for a metal object to be pulled by a magnet, it must have enough of one of these metals that are magnetic. One of these metals that are attracted by a magnet. Now, paper clips, we know, are attracted by magnets, and paper clips are made out of metal called steel. And steel has iron in it. And iron is one of those special metals that are attracted by magnets. So not all metals are attracted by magnets, only certain ones, including iron, nickel, and cobalt. Let's try this spoon. Now again, get your prediction. Will this spoon be attracted by the magnet? Let's try it. Look at that. This spoon is very attracted by the magnets. So what does that tell us about this spoon? This spoon is made out of one of these special metals. Now it probably has other metals in it as well, but it has enough of either iron, nickel, or cobalt for it to have a very good attraction to these magnets. Do you think that wood will be attracted to the magnet? Let's try it. Nope. Wood is not attracted by magnets. Let's try this. It is. You see, this is a metal object that is attracted by the magnets. Now let's try this can. If we put our magnet on top of the can and tip the can over, notice that it has no attraction here. If we put it on the side of the can, again, there's no attraction here. Well, remember, cans like this, soda pop cans, are made out of aluminum. Aluminum is not one of those special metals. And so, the magnet has no attraction to it. So aluminum is not attracted by the magnet. Let's try this can. Now this can is made out of something else. Look how the magnet will stick to it. So there's magnetic attraction here. You can see the magnetic force. We put it on the top. Well, this can is not made out of aluminum. And let's try one more thing. How about we try this battery? Well, again, we found another object that is attracted by magnets. So some metal objects are attracted by magnets and some aren't. But objects such as wood or plastic are not attracted by metal objects. If we got a crayon, which is made out of wax, it's not attracted to the magnet. Now there's one more thing that I want to talk about that's really interesting about magnets. Now magnets have a north side and they have a south side. And when we have two magnets, notice that this magnet is shaped like a horseshoe, but it also has a north and a south. Now when we have two magnets, if we put both of their north sides together, they will repel, which means they will push against each other. Watch this. It's moving away because it does not want to go to that north side. But if we put the south side by the north side, watch what happens. They're attracted. So like charges repel, but unlike charges attract. And sometimes it's really fun to play with two magnets because you can make them kind of dance. If I put the if I put the two north sides together and I put the two south sides together, I can kind of push the other magnet along. And notice that they're not even touching because this magnetism is a non-contact force. But we can see that there is a force here pushing these two apart. It's incredible. Now it's really fun to use a magnet and go around your house and test different objects to see if they are attracted by magnets or not. And it's